So hello everyone. In this video, I'm going to discuss collision resolution using one of the scheme called open addressing scheme. All right. So just to revise, we have in hashing we have a hash table, we have a hash function, and we have a key value pair. Okay. So the hash function takes the key as its parameter and then computes the address where the key value needs to be inserted or where it is located. Okay. But if two different key values produce the same hash value or address, then we say that collision has occurred. Okay. Because we can only store one key value pair in a slot. If another key value pair produces the same address, then I cannot store that key value pair where a slot is already occupied by some other key value pair. Okay, so I need to find a new slot for this key value pair for which collision has occurred. So this in open addressing scheme, we send a probe. Okay, so we send a probe, and the purpose of the probe is to check a particular location in the hash table to see if a slot is available. If a new slot is available that is empty. So if we send a probe and it returns true, which means that another slot is available, and if that is available, then we store this key value pair in that slot. Okay. Now, if the probe returns false, that means the probe identifies a new location in the hash table, but even that slot is occupied, then the probe has failed. So what we do is we send a second probe to a new location and to see if another slot is available. So we keep doing that until the probe is successful. So basically, once if a probe is successful, then we have located a slot in the hash table that is available, so that we can store this key value pair over there. Okay, so that is collision resolution. So there are many collision resolution techniques. I am going to probably cover this linear probing and quadratic probing. Okay. So here is an example. In this, we have 300 employees. So it is good to choose the size as the nearest prime number. Okay, so I have chosen 307, which is greater than 300 and which is a prime number. Prime number has a property that it kind of distributes the keys uniformly across a hash table. Okay. So we prefer a prime number over 300, which is an even number. Okay. So here we have the hash function that takes the input as the key value. So I'm using modulo division to compute the hash value. So this hash value is nothing but this address over here, and I call this a slot. Okay, this key value pair is nothing but a slot. Okay, and its address is here. Okay. Now, here is first key value pair. Just remember that here I'm inserting the key value pair into the hash table. All right. So if I have some employee whose key value is 379452, I'm going to do a modulo division and compute the hash value as 1. Okay, this here is a computation. I have already talked about division method. Please go through that video. So if I get hash value 1, I see that this slot is empty, so I can insert that. Second employee, key value, and then we have hash value as 2, and this slot is also available, therefore I insert it there. Now third employee, this is the key value, and the hash value or the address is 3, and that slot is available. So here I'm going to insert that. Now the fourth employee has a key value, but here the problem is it is generating hash value as 2. So but 2 is already, the slot for address 2 is already occupied by some other key value pair. So I cannot insert this here, otherwise I will be overwriting what is already here. So I need to find a new slot. For that, I'm going to send a probe. So, okay, so somewhere I'm going to give the probe index value or hash value, and to check if that particular key value slot is available. If it is available, then the probe is successful. If the probe fails, that means even that slot is occupied. Then I'm going to send the second probe, and so on.